Hello everyone, my name is Nabila. I'm Septiani. I'm studying statistics at Universitas Islam Indonesia. So here I want to show you my result of my analysis. So the data set display represents a mortality statistic by country, year, and age group. Each row corresponds to a specific age group with a given country and year. The guide columns can be explained as follows: region codes, and region name. These columns indicate the geographical region. For example, AU for Europe shows that the country is located in the Europe region. The country code and country name. This identify the country being observed. For example, in this example, ALB for Albania is the country interest, and your the specific of your observation. Six column show the gender category. The value all indicates that the data is aggregated for both males and females. And group code and age group is provide the specific age range for each observation. Uh, number. This column shows the absolute number of deaths recorded in this specific age group, country, and year, and percentage of cause-specific deaths out of total deaths. This indicates the proportion of deaths from a specific cause relative to the total number of deaths in that country and year. For example, no, and age standard death rate per 100,000 population. This column shall contain the mortality rate adjusted for age, allowing comparison between population with different age structure. Uh, in this pin, the value are currently NIN or missing likely because they are calculated at an grade level, not for each age subgroup. And the rate per 100,000 population. This is the current death rate of each age group expression per 100,000 people. And related to the data I have, namely about stomach cancer. So the question I have is how can mortality indicates be used to group countries into low, medium, and high mortality levels? So So in this analysis, our main objective is to identify patterns of mortality rates across different countries using statistical exploration and clustering methods. We focus on three indicators: the percentage of cause-specific deaths out of total deaths as standardized death rate per 100 standard population and death rate per 100 population. These indicators are essential to understand the global burden of mortality and provide valuable insight for healthy policy prioritization and strategic interventions. At the beginning of the analysis, we explored the data distribution through boxplot. The initial boxplot clearly showed that the distribution of all three variables is highly scaled to the right with many extreme outliers. This means that while most countries have relative low mortality rates, a few countries experience extremely high values. These scale signals need to further data transformation or standardization before applying a clustering algorithm to ensure fair and accurate classification. Next, we examine the descriptive statistic of each variable, the mean of the age, standardized death rate is around 13.44 per 100,000, while the maximum reach 149.36. The medium of the credit rate is 3.12, but the maximum can be as high as 1,500 per 100, 15,000 per 100,000. Is very wide range suggests that the data is not normally distributed with significant variation between countries. This reinforces why standardization is essential before future analysis. To address this issue, we apply standard scalar. This technique adjusts the variables so that they have a mean of 0 and standard deviation of 1, making them comparable on the same scale. After standardization, the backplots show at the distribution are centered around 0 and the scale difference are minimized. And this step is crucial because K-means class is sensitive to scale. And with our standardization variable, range called the Newton result. So next K-means clustering result. After pre-processing, we apply K-means clustering with 3 cluster in the resulting scatter plot with category high, low, and medium. So in this plot, the x-axis represents the age standardized death rate. The y-axis represents the group death rate, and the color coding indicates 3 different cluster: green high death rate, blue medium death rate, and teal low death rate. There is a clear upward trend between the two variables as the age standardization death rate increase, the cure death rate tends to increase as well. The cluster are visual well separated, reflected K-means effectively classify countries based on their mortality levels. And low cluster country with a low mortality possible due to strong health system, better health access or lower disease burdens, and medium cluster country with moderate mortality like in traditional health condition or with a varying resource, and high cluster countries with a significantly high mortality indicates serious health challenge that need focused attention and intervention. So you can see the member country of region in cluster low, high, and medium. So that's my analysis result. Thank you.